Hello friends, welcome back to the video lecture. In this video we are going to see the second titration, that is titration of weak acid and strong base, okay, from the volumetric analysis. Now here the weak acid taken is 0.1 normal acetic acid and the strong base taken is 0.1 normal NaOH. Here again the sodium hydroxide solution, that is NaOH solution, is taken in burette, so that's why it is titrant, and 0.1 normal acetic acid is titer or titrant. Okay, so we have taken 25 ml of 0.1 normal NaOH in burette. So this is burette solution, base is taken, and with the help of pipette we have pipette out 0.1 normal acetic acid, okay, 0.1 normal acetic acid 25 ml in conical flask. So in conical flask we have at the start only acetic acid, it is 0.1 normal CH3COOH, okay, 25 ml of acetic acid is taken in conical flask with the help of pipette, and in burette we have 0.1 normal NaOH solution. Now the nature of the graph for this titration of weak acid and strong base is like this. The graph is plotted for you, and this graph is plotted as pH versus ml of NaOH added. pH as a function of volume of sodium hydroxide, that is base, added from the burette. Okay, so this is the graph. So what is the features, what are the features of this graph? So at the start of titration, at the start of reaction between these two chemicals, the pH is increasing linearly, the pH is increasing slightly, okay, and at the start of reaction, as we have only acetic acid in our conical flask, the pH is in the acidic range. Okay, so at the start of reaction or titration, the pH is around about 2 to 3. The pH is about 2 to 3 of the pH units. Okay, the reaction between these two is very simple, and we can write here CH3COOH plus NaOH. So this is acetic acid and this is sodium hydroxide. There is a formation of sodium acetate, CH3COO(Na). The salt is formed plus solvent, that is water, is formed. Okay, this is the simple reaction between the weak acid, acetic acid, and strong base sodium hydroxide, resulting the formation of sodium acetate salt and the water solvent. Okay, so now we have to see the characteristics of this graph. So at the start of this reaction, at the start of this titration, the pH is around about 2 to 3 units, okay, and at the equivalence point, the equivalence point of this titration is around 6 to 10.5 pH units. The equivalence point is on the vertical line of this curve, okay, and it is about around the 6 to 10.5. So approximately 6 to 10.5 units of the pH units in this vertical line, the equivalence point of this titration lies. Okay, now for this we have to consider the different indicators. So next point is choice of indicators for this titrations. So the main 4 indicators which has transition range pH values in this range that we have considered here, that is methyl orange, methyl red, bromothiamol blue, and phenolphthalein. Okay, now the bromothiamol blue has the transition range from the 6 to 7.6, and phenolphthalein has a transition range from 8 to 10.1, around about that. Okay, so both these indicators, that is phenolphthalein and bromothiamol blue, are the suitable indicators for this titration, but as the equivalence point of this titration lies near to this at2, it is around about at2 10.5. okay, so that's why phenolphthalein, which has a transition range in this range, okay, so that's why phenolphthalein is used as a best indicator for this titration. okay, no doubt both can be used, but phenolphthalein gives us the accurate results for this titration. So that's why phenolphthalein is can be considered as a best indicator for this titration of weak acid and strong base. okay, now we have to we have to calculate the 4 pH at the different stages of the titration. We have to calculate the pH values for at the different stages of the titration for the titration of weak acid and strong base. So let us calculate first the pH at the start of the titration. So pH at the start of titration. For this we have to consider, we have to remember, at the start of titration we have only acetic acid, that is 25 ml 0.1 normal acetic acid in our conical flask. okay, so our first attempt is to calculate pH at the start of reaction, pH at the start of titration, pH at the start of titration. okay, so at the start of this titration we have only 0.1 normal acetic acid in the titration flask or in the conical flask. okay, so acetic acid is a weak acid and it dissociates like acetic acid is a weak acid, it does not dissociate completely, but it dissociates partially, and it is like partial dissociation is there into CH3COO minus plus H plus, CH3CO minus plus H plus. okay, so at the equilibrium the concentration of this acetic acid will be 0.1 minus X, 0.1 minus X. So what is this? At the start we have only 0.1 normal acetic acid. X is the degree of dissociation of this acetic acid, and it will form X moles, X millimoles of this acetate ions, and X moles of H plus ions are formed. Why we have writing here this equation? We have to calculate the pH, and there is a link, there is a correlation between the H plus ion concentration and pH. That is why we have to first know the concentration of H plus ion, then we can calculate the pH of the solution. okay, so these are the concentration at equilibrium. Concentration at equilibrium. Acetic acid is a weak acid and its dissociation constant Ka for acetic acid is 1.75 into 10 raised to minus 5 at 25 degrees Celsius. So 25 degrees Celsius is taken as the room temperature worldwide. A constant temperature is taken for the calculation purpose. So at this temperature the dissociation constant is Ka is equal to 1.75. This is a constant figure, it can be obtained from the any literature or any data. 1.75 into 10 raised to minus 5, this is for acetic acid at 25 degrees Celsius. Now we have to calculate here the concentration, the dissociation constant Ka. For this equation we can write the concentration of acetate ion CH3COO minus into concentration of H plus divided by concentration of undissociated species. This is concentration of acetic acid CH3COOH. okay, now it is equal to concentration of acetate ion is X. These are the concentration at equilibrium. So okay, so this is X into concentration of H plus is again X into X divided by concentration of acetic acid is 0.1 minus X. Now as X is very small, acetic acid is a weak acid and X is a very small because it dissociates very partially or very less amount of acetic acid is get dissolved. So that's why as X is degree of dissociation, so X is very small, we can write 0.1 minus X is approximately equal to 0.1. So x is very small, we can neglect it. So x into x, it is x square, and 0.1 minus x, it becomes 0.1. Okay, so x square is equal to x square upon 0.1 is equal to Ka. But what is Ka? Ka is 1.75 into 10 raised to minus 5, okay, is equal to x square divided by 0.1. So 0.1 is at the denominator. From when we take it on the LHS, it becomes numerator. So this into 0.1, it will become 1.75 into 10 raised to minus 5 into 0.1. So it will become x square. So that's why x square is equal to 1.75 into 10 raised to minus 5 into 0.1, it becomes 10 raised to minus 6. So that's why now we have to take a square root of this. So concentration of H plus is nothing but x. Concentration of H plus is x, and what is x? We have to take the square root of this. X is equal to square root of this, it becomes 1.75, square root is 1.313 into 10 raised to minus 3 moles. This is the concentration of H plus, which is the value of x. So the value of x is taken from the square root of this. You can use your calculator, okay, and the value becomes 1.313 into 10 raised to minus 3 moles. Okay, so now we have to calculate the pH. So therefore pH is equal to log of 1 upon H plus ion concentration, and that is equal to log of 1 upon, what is H plus ion concentration? 1 upon 1.313 into 10 raised to minus 3. So if you solve this equation, the pH of your solution at the start of titration becomes 2.88. The pH becomes, you can solve this by using calculator. So pH becomes, the answer will be 2.88 units. So this is the pH. So you can recall what is the nature of graph. At the start of reaction, at the start of titration, the pH is towards the acidic range, because only acetic acid is there in the conical flask. So at the start, the pH is round about at near to 3, that is 2.88. okay, so this is a very simple calculation to calculate the pH at the start of a titration. Now the next point is pH of the solution when 10 ml of sodium hydroxide, that is NaOH, is added to the 25 ml of 0.1 normal NaOH. This is the second pH calculation. pH when 10 ml of acetic acid CH3COOH added to 25 ml 0.1 normal 10 ml of NaOH added, 10 ml of NaOH added to 0.25 ml 0.1 normal acetic acid solution, and this solution we have taken in flask, conical flask, and this 10 ml of solution we have added from the burette solution, that is NaOH solution. Okay, now in this case the calculation is bigger one, and it requires some more steps to calculate the pH at this stage. Okay, now consider here, at the start we have only acetic acid in our conical flask, it is 25 ml. From the burette we have added 10 ml of NaOH. So this 10 ml of NaOH will react with 10 ml of acetic acid, and hence 25 ml acetic acid is there, 10 ml will react with NaOH. So remaining acetic acid unreacted, the acetic acid unreacted remain unreacted in the conical flask will be 25 minus 10 and it will become 15 ml. So only 15 ml of the acetic acid is remaining to be unreacted at this stage. Okay, when 10 ml we are adding, so 10 ml react with 10 ml of acetic acid. So acetic acid remain unreacted in conical flask is only 15 ml. Now when we are adding NaOH, the volume of the solution is increasing, and as volume is increasing, the concentration of that acetic acid is also changing. Okay, so that's why the concentration of the acetic acid, a new concentration of acetic acid in the conical flask can be calculated by using the formula N1V1. Okay, so for this simplification we have taken, this is old solution first, this is new solution second. Okay, N1V1 is equal to N2V2. So this is a universal formula. A product of normality and volume is always constant. Okay, so N1V1 is equal to N2V2. So what is the first previous normality of the acetic acid? It is 0.1 into volume, old volume is 15 ml. Why we have taken 15 here? Because only 15 ml of volume is now remaining to unreact with the to be unreacted. Okay, now N2 we have to calculate, and what is the V2? New volume. So we have 25 ml already in conical flask and 10 ml of the NaOH is added from the burette. So 25 plus 10, 35. So 35 ml is the new volume for the conical flask, in the conical flask. So N2 into 35. So N2 can be calculated 0.1 into 15 divided by 35 divided by 35. So the new normality or the new concentration of this acetic acid solution, the answer will be 0.042 at 6, 0.042 at 6 normal. Okay, so this is the concentration of acetic acid in the conical flask when we are adding 10 ml of NaOH from the burette. Okay, now this figure is important for the further calculation. Okay, so I am rubbing it, and this value is important, so I am putting here. So N2 is, mind well this value, remember this value, N2, this is not nitrogen, N2 is normality or the concentration of acetic acid after adding 10 ml of NaOH. So it is 0.042 at 6 molar or normal, let us say. We are calculating the pH of the solution when 10 ml of NaOH added. Okay, now the neutralization reaction at this stage is CH3COOH plus NaOH, can be shown like this. It is forming CH3COONa, sodium acetate plus water. Sodium acetate plus water is formed. Okay, so acetic acid, what is the concentration? 0.1 into 10. So 0.1 ml of 0.1 normal acetic acid is taken, and 10 ml we have so 0.1 into, sorry, sodium acetate is there. Yes, sodium acetic acid is there. So acetic acid is taken 10 ml. Acetic acid is taken in 10 ml, and so neutralization reaction is there, means only 10 ml of the acetic acid from the 25 ml is reacting with the 10 ml of the NaOH added. So from this point of view we have written here the reaction. So 10 ml is reacting, the concentration is 0.1. So 0.1 into 10 plus it is again same 0.1 into 10, and from the reaction between these two, both are, the volume of both the reactants are 10 ml, they are reacting, and 0.1 into 10 is 1. So 1 millimole of the sodium acetate is going to form. 1 millimole of the sodium acetate is going to form. Now the molarity or the normality of this sodium acetate can be calculated. So the concentration of sodium acetate CH3COO_Na, concentration of the sodium acetate form can be calculated is equal to millimoles of sodium acetate form, millimoles of sodium acetate formed divided by volume, total volume in ml, So we are calculating the molarity or normality. So molarity can be calculated of this sodium acetate. It is equal to millimoles, is 1 millimole is forming, and total volume is 25 plus 10, that is 35. 25 plus 10, that is 35, and 1 upon 35, the answer is, you can calculate your calci, 0.02857 molar. So this is the concentration of molarity of the sodium acetate, that is salt form. Okay, now at every stage of this titration, before equivalence point, so before equivalence point, now we have in our conical flask acetic acid is there, we are adding NaOH, that is base from the burette, and before equivalence point at every stage there is a formation of acidic buffer, because there is acetic acid weak base and a strong base NaOH, a combination of these 2 to 3 chemicals is there. So there is a formation of acidic buffer in this solution in the conical flask, and hence the concentration of H plus ion of this acidic buffer can be calculated by using a formula. Concentration of H plus ion is equal to Ka into concentration of acid divided by concentration of salt. Concentration of acid divided by concentration of salt. Okay, now what is Ka? We know that it is 1.75 into 10 raised to minus 5, okay, into concentration of acid. What is the concentration of acid? That we have calculated here. It is 0.0486 divided by concentration of salt. This is salt, sodium acetate is the salt, and it is 0.02857. Okay, so when you solve this sum, a multiplication of 2 to 3 numbers, okay, and division is there, so H plus ion concentration becomes 2.625 into 10 raised to minus 5. So this is H plus ion concentration. So as we know H plus ion concentration, we can easily calculate the pH of the solution. pH is equal to log to the base 10 of H plus ion concentration, or negative log to the base 10 of H plus ion concentration. Same meaning is there. So it is equal to log of 1 upon this figure, and the pH of this solution. Okay, it becomes, the answer will become 4.581. So this is the pH of the solution after adding 10 ml of strong base NaOH from the burette. Okay, so this is the way that we have to calculate the pH of the solution. Okay, so number of steps are there in this calculation. You have to remember all these steps. Okay, now the third step is this is second step, this was second step. Now third step is the pH at the equivalence point. pH at the equivalence point. So third calculation is there. We have to calculate the pH of the solution at the equivalence point. In your exam, any titration can be asked for the long answer type of question. pH of the solution at equivalence point. pH at equivalence point. So this is the third calculation. Okay, now at equivalence point, what is the situation? 25 ml acetic acid that we have taken in conical flask, it will react with 25 ml of NaOH solution that we have added from the burette solution. Okay, so the total volume becomes in your flask will be 25 plus 25, it will be 50 ml of volume. Total volume will be 50 ml. And what will be the situation? The situation will be all the H plus ions from the acetic acid will consume totally, but it will react totally with the OH minus ions or NaOH from the burette solution. Okay, and there is a formation of salt, that is sodium acetate, and water. Okay, and this neutralization can be shown like this: CH3COOH plus NaOH, formation of CH3COO Na plus water. Okay, so 0.1 concentration is 0.1 acetic acid. What is the volume taken? 25 ml. It will react with 0.1 normal NaOH. Volume taken at equivalence point, we have taken 25 ml of NaOH added. Okay, so 0.1 into 25, again 0.1 into 25, it will form how much? 2.5, the multiplication of these two, 2.5 millimoles of sodium acetate will be formed at this stage, at the equivalence point. So concentration of sodium acetate CH3COONA, that is concentration of salt at the equivalence point, can be calculated by using the formula millimoles of concentration, means we are calculating the molarity. Millimoles of, what is the formula of molarity? Moles or millimoles divided by the volume. Millimoles of sodium acetate formed divided by total volume in ml. As we have taken the volume in ml, so we have to consider the millimoles instead of moles. As we have if we are taking the volume in liters, then we have to consider the moles instead of millimoles. Then the millimoles formed here 2.5, and total volume is 25 plus 25, it becomes 50. The ratio of this will become 0.05 moles. So the molarity of sodium acetate CH3CONA formed in this titration at equivalence point is equal to 0.05 molar. Okay, so this figure is important, concentration of sodium acetate. Now this sodium acetate CH3COO minus plus, it undergoes hydrolysis plus H2O. So all the solutions are aqueous solutions, means water is there, and as it is formed, so it undergoes hydrolysis in presence of water, and on hydrolysis it will form CH3COO minus, sorry, CH3COOH plus OH minus. You may write CH3COONA plus H2O giving CH3COOH plus NaOH. You can write in both of the ways. Okay, so this is the reaction of hydrolysis of sodium acetate form or sodium acetate ions form in these reactions. Okay, now the concentration of this is 0.05. किती concentration है? Sorry, what is the concentration? 0.05 molar. Okay, minus y. Minus y means as this is the concentration, out of this y millimoles of these acetate ions or sodium acetate will undergoes hydrolysis. So this is the fraction. Okay, and it will form y millimoles of acetic acid and y millimoles of hydroxide ions. Now we have to consider here we have to calculate here the OH minus ion concentration. Okay, so the hydrolysis constant KH for this reaction we can write here concentration of CS3COOH into concentration of OH minus divided by concentration of CS3COO minus. As water is taken in large excess, its concentration remains as it is. So Y into Y divided by 0.05 minus Y. Again the degree of dissociation, that is Y, is very less. So that's why it becomes Y can be neglected from the denominator and it becomes KH is equal to Y into Y square divided by, it can be neglected, so it becomes 0.05. Okay, but we have one formula for KH, and that is KH is equal to KH is equal to KW upon Ka. KH is equal to Kw upon Ka. What is Kw? This is the ionic product of water and it is 1 into 10 raised to minus 14 divided by, what is Ka? 1 into 10 raised to 1.75 into 10 raised to minus 5. So by solving these two equations, this ratio, you will get the answer, that is 5.714 into 10 raised to minus 10. This is the value of KH. Now this value of KH, that is 5.714 into 10 raised to minus 10, we can put this value in this equation, and this equation becomes KH, that is 5.714 into 10 raised to minus 10 is equal to Y square divided by 0.05. So therefore Y square is equal to multiplication of these two, that is cross multiplication is there. Okay, and the value becomes 28.57. all are these numbers, so you can use your calculator for this. 28.57 into 10 raised to minus 12. This is the value of Y. Now you can take the square root of this, so value of Y, that is square root of this, and Y is nothing but concentration of OH minus. So concentration of OH minus is equal to Y, and it is equal to the square root of this, and the square root is become 5.345 into 10 raised to minus 6. So this is OH minus ion concentration. So therefore POH is equal to log to the base 10 of 1 upon OH minus ion concentration. This is OH, POH, formula for POH, and if you put this value in that formula, then POH becomes 5.272, and once you have the POH value, you can calculate the pH. pH is equal to 40 minus POH, and so therefore 40 minus this figure, the answer will be I think 8.728. So this is the pH of the solution at equivalence point, means when 25 ml of NaOH is added to 25 ml of acetic acid. This is the third calculation, and the only one calculation is remaining, and that is the pH of solution when extra 1 ml, that is 26 ml of NaOH base is added from the burette. So what will be the pH? Okay, so in your exam or in your notes, at least 3 to 4 calculation must be there for the calculation of pH if the question is long answer type question. Okay, so pH at the pH, fourth calculation, pH when 26 ml, pH when 26 ml of NaOH added to 25 ml 0.1 normal acetic acid. Okay, now what is the situation? Up to 25 ml, all the acetic acid which was taken in the conical flask, it is get neutralized by the 25 ml of NaOH added. Now in our conical flask, 26 plus 25, the total volume will be 51 ml, and the only unreacted 1 ml NaOH is remaining. Only unreacted 1 ml of NaOH is remaining in our conical flask. Okay, so for that the pH must be now towards the alkaline side or towards the basic side. So we have to calculate here first of all the OH minus ion concentration, as we have only NaOH, 1 ml NaOH is more than the equivalence point in our conical flask. So this is the key how to remember all these steps. Okay, now for that the total volume will be 51 ml, and the OH minus ion concentration in this case is equal to millimoles of OH minus ions divided by millimoles of OH minus ions divided by total volume in ml. So millimoles of OH minus, it is 1 millimoles of OH minus, it is 1.1 concentration is there into 1 ml is extra, and total volume is 51. So 0.1 into 1, 0.1 divided by 51, and hence OH minus ion concentration is equal to, it becomes 2.7077. This is OH minus ion concentration. Therefore POH is equal to log to the base 10 of 1 upon OH minus ion concentration, and it is equal to, when you put the value of this into this equation, it becomes POH is, OH minus ion concentration is 0.00196 molarity. So and pH becomes 2.7077. So this is the value of pOH. Therefore pH is equal to 14 minus pH and is equal to 14 minus 2.7077, and therefore you can easily calculate the pH. It becomes 11.292. So this is the pH of the solution. This is the pH of the solution when extra 1 ml, that is 26 ml of NaOH is added to the conical flask containing 0.1 normal acetic acid. Okay, so this is the simple way to calculate the pH at the different stages of the titration between weak acid, acetic acid, and strong base NaOH, that is sodium hydroxide. Okay, so this is all about the second titration and the calculation and nature of curve about the second titration WASP. Okay, thank you very much.